All. Good evening, Lucky. Good evening, everyone. Sriram, Shubham, Danpal, Rudraksh, Harsh, Ruchita, Sonali, Rahul, Sumit, Deep, Ganesh, Kuldeep, Rohit. Any bass is little high. Okay, my original voice. How I can know? Good evening, Matthews. Yes, Mark joined us. What's up? You feel any difference? Okay, good. Pranit sir got it. I will talk to you. Logical group of instruction. Yes, today questions after this logical group, we will do good number of questions. Hopefully, not hopefully, definitely. Okay. So in the logical group of instructions, we have AND operation, OR operation, XOR operation, compare, complement, rotate. Yesterday I told those things already. Okay. And now I will show you the first one in this AND operation. What is the first one? AND operation. AND operation is given by first instruction in the AND operation is ANAR. Okay, ANA means AND accumulator. What is the meaning of ANA? AND accumulator. So that is your accumulator is copied with A and with R. Okay, what is this meaning? Bitwise AND. That is bitwise, individual bitwise AND operation will be taking place. Now listen here. For example, your A is having 35 hexadecimal. B is having 25 hexadecimal. I say AND accumulator with B. What happens is 35 means 0011. 5 means 0101. 25 is 0101. 0101. Then it will perform AND operation. You get 1 0 1 0. 1 XOR with 1 and 0 1. So what is the answer? You get 25. This is what we call AND operation. Just logically bitwise AND operation only. So this is done with the help of AND accumulator with register R. Now tell me these things again. It is 1 byte instruction. 1 byte instruction. 1 machine cycle. 1 byte instruction. 1 machine cycle. Then opcode fetch only 40 states. Opcode fetch and 40 states. What is the addressing mode here? Register addressing mode. And all flags affected, but carry will be 0, auxiliary carry will be 1. After AND operation, irrespective of your data, irrespective of your accumulator and register, carry is always 0, auxiliary carry is always equal to 1 in the AND operation. This is why examiner has made this. Maybe not examiner, I'm sorry, why I'm calling examiner, manufacturer. Okay, why manufacturer has made this is because maybe to set the auxiliary carry, he may use this instruction. Okay, there is no way to set the auxiliary carry directly. This is one way we can use to set the auxiliary carry. Whenever you perform AND operation, auxiliary carry will be always made equal to 1. Auxiliary carry will be always made equal to 1. Carry 0, I need not say. Actually, I need not say carry 0. Why? AND operational will not generate any carry. You know it already. AND operation will not generate any carry. So, after AND operation, always carry equal to 0. Here, no use Aditya. But in any program, suppose you want to use auxiliary carry. You want to set auxiliary carry, like in BCD operations. There, you may be use it. Okay. What happened, Anuj? Only register. Register is how many bits? Register is 8 bits. That's all. Register is 8 bits. Okay. Next. What is NOAC? Now, accumulator equal to 0. AC equal to 0. No, AC equal to 1. In any AND operation, after AND operation, accumulator will be equal to 1. Okay, let's continue. Today, camera is different. You observed? Any difference? Let's have old one is good, I think, right? More darker this one. This one is best, I think. That is good for this one, what we call. For YouTube, it is good. I am not speaking anything. Okay? Right. Let's move. Yes, Nishita. All arithmetic and logic operations result is stored in accumulator only. In all arithmetic and logical operation, result is stored in accumulator only. Is it okay? Let's move. Let's move faster. Next instruction. And immediately 8-bit data. I should say you few things. Okay, blindly if I say this AND or XOR, it is of no meaning. I need to explain you where we use this. That is important. Application, where we use it. Okay, so I need to explain that. I will explain you definitely. So see here, first AND immediately 8-bit data. So here what happens? Let's take one example of AND immediately some 25. Here the number will be stored immediately in the computer. So it requires one opcode fetch and also what? Memory read. And immediately. So here, what are your conditions? 1 byte, 1 machine cycle, OF. Okay, oh, not 1 byte, 2 byte, 2 machine cycles, opcode fetch plus memory read. Please understand one thing. Here, you have fetch execution overlap. because we calculated only 4 T states. When this end operation will take place, during the fetch of the next instruction, this execution will take place. Okay, so that register will be copied into temporary register, then temporary register will be performed this end operation and all those things. Yes, very good. Pipelining operation. So 2 machine cycles, opcode fetch memory rate, and 4T plus 3T, 70 states. 70 states. Yes, immediately data available in the instruction itself. Immediate addressing mode. How many flags are affected? No flag affected. Sorry, why no? Rule is same. All flags affected, but carry equal to 0. Auxiliary carry equal to. Shall we move next? Okay, little fast I will go because it is a similar things we are discussing. So let's go little fast. Next one. Next one. And accumulator with memory M. And accumulator with memory. Here what happens? Accumulator is end operated with what? Contents of HL register. Here accumulator is end operated with the number 25 directly. Here it is 25 directly. Here it is end operated with the memory location, that is HL register pair. So here please listen. Let's take one example for your understanding. Say HL is already having 3200, some random number is taken. Okay, if I say and accumulator with M, what happens? Accumulator will be copied with A and operated with HL. That is the contents of memory location 3200. Here bracket is kept means now you understand our terminology, right? So you have opcode fetch only one. Then computer will go to 3200. Some number 40, something is there. It will read that data into temporary register. So where it will read a temporary register. Then accumulator is end operated with 40. Okay, so this is where it happens is in FEO. Very good, people. So this is what happens. So what is your total 1 byte instruction? 1 byte instruction. 2 machine cycles. Opcode fetch plus memory read. 70 states. Okay. What is addressing mode? Register indirect. Very good. RI. Right. Okay. Same rule. All flags affected. Carry is equal to 1. Auxiliary carry equal to carry 0. Auxiliary carry 1. Very good. Very good. So let's save some time. I don't want to write this again. So even you, that is a manufacture. Actually, there is no carry generation in this end operation. Actually, there is no meaning for carry and auxiliary carry in this end operation or any operation. I mean, any logical operation will not give you any carry. But that's why carry will be always 0. Here auxiliary carry is made 1 so that to indicate, suppose to set the auxiliary carry, you can use this instruction. It is of no use for us actually. It is made by manufacturer. Good. Harsh, you are not there in the morning today? Asif is there. Now, where this logical will be used, I will explain you. Don't worry, Aditya, just wait. Okay. So finally, I think you people made what we call harsh internet also becomes slow because everybody praised his internet connection. It happened. No, in the morning. So I'm just taking this screenshot so that we can save some time instead of writing every again same thing, same story. I didn't made it. I mean typed because if we write, you can remember. That's why. So now he is waiting. I think. So where is micro? Yes. We save time to write 6 instructions. So now what I can do? This is right. Now in the logical group, listen here. The next one in the logical group is OR operation. So what is the next one in the logical group? OR operation. ORA. That is OR accumulator. A equal to A or R. That is bitwise OR operation. Okay. This is one instruction you have, and also you can have XOR operation. For XOR operation, what is the instruction you are having is XOR A R. That is accumulator is copied with A XOR R. Accumulator is copied with A XOR R. Okay. Next. Yeah, bitwise only. Why are you asking that? Okay, remaining all relations are same, but carry and auxiliary carry both 0. Why 0? Because logical operation will not generate any carry or auxiliary carry. Logical operation cannot generate because it is not addition or subtraction. It is logical operation. So it cannot generate any carry or auxiliary carry. By default, they will be 0. No doubt in it. So it is OR and XOR operation. What is the only difference is this carry part. Next. Similar to end operation earlier we have discussed. Now we discuss ORA. Okay. That is OR immediately 8-bit data. A is equal to A or 8-bit data. Similarly, another instruction is XRI. XRI is XOR operation. A equal to A XOR the 8-bit immediate data. It is same as the previous case, but here both will be 0. This is OR XOR. Next. So it saved our time like anything, I hope. So total how many instructions we learned today till now? It is 3 types. I think 9 instructions are completed now, right? So similar to AND operation, we have OR and XOR operation. You can OR accumulator with memory location, and also what is the another instruction you have XOR accumulator with memory location. A equal to A XOR content of memory location. A equal to A or content of memory location. So same story, auxiliary carry is 0. So that is about your first group of logical operations. So let's start or let's do few questions before going to the next set of instructions, because you are waiting for problems from long time. Okay, get ready guys. One logical question for you is loading. Wait, more how many classes? What is that, Aditya? Char more. Okay, your poll ready? Tell me the, don't tell. If you say you are ready, I will start the poll. In this case, I forgot to tell you one thing. Please listen. If you XOR A with A, this is one of the important instruction. A will be copied with A XOR A. What is A XOR A? Okay, so this is one of the instruction used to clear accumulator with less T states, because it requires only, where is that? That is 4 T states only. Okay, this is not I am saying XRA M, XRA R instruction. Okay, this point I want to give you, that is, it is not this one. Okay, it is not this case. There is no way. If you want to move 0 to the accumulator, it requires 70 states, because MVI instruction is 70 states. But if you do XOR A with A, it requires only 40 states. Okay, I will come to that question. Forget about it just for 1 minute. If I say MVI A comma 0 0, accumulator will be 0 0 na, here 4 T states plus 3 T states, total how much? 70 states. I told this, opcode fetch and memory read. If you do XOR A with A directly, this requires only 4 T states. So this is the best one. To clear accumulator, we use this XOR A instruction. Okay, A XOR A is 0. So Now do this question. I will start the poll. Okay, let's start the poll. Okay, very less right answers. So what is the right answer? You believe in me? Answer is 76, not 0. What happened, Aditya? Don't worry. I am there now. Okay, see here. Here, first, examiner has given this program. He has given mnemonics and opcode also. This is the opcode corresponding. Okay. So what is the opcode of HLT instruction? HLT means what? Halt. Halt instruction ka opcode kya? 76. Like that, opcodes are given by examiner. Okay. Let's see how this will work. Firstly, MVA A comma 36H. So you take the memory. Let's understand this with the help of memory. So it is 3000, 3001, 3002, 3003, 4, 3005, 6, 7, okay, 3008. Everybody knows this. How the computer stored the program is AE 36, 82, 40, 32, 07, 30, 376. Yes or no? This is how it is 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Total 9 are stored. Okay, first let us understand this now. First, accumulator is copied with 36. Happy. Aditya, are you happy? Add immediately, accumulator is copied with 36 plus 40, which will give you 76. Add immediately 40 to the accumulator. Then, store accumulator in where? 3007 memory location. So, 3007 is now copied with 76. Carefully understand. 3007 is now copied or replaced with what? Accumulator. That is how much? 76. So 3007 may whatever you have, this data now becomes 76. So this is eliminated here. Okay, this will not be run. It is overwritten. By the time computer comes here, this line will be gone. It is replaced by 76. What is the meaning of 76? Examiner has given that it is halt. So program will be stopped. Okay, so that's why I explained XOR A into A is 0. It will not become 0 in this case because it will not run. Understand? Okay. Wait. Listen here. This is the program. So see here, up to this part, A is copied with 36. The store accumulator into 3007 memory location. So 3007 memory location may whatever the data is there, it is replaced with now how much? 76. So this number will be replaced by 76. That XOR A, computer will not do this XOR A because by the time computer comes here, you are not having 3E. 3 is replaced by what? 76. 76 means what? As per the program, as per the table. 76 means what? Halt. Computer will halt. You understand? Actually, if there is a 3E here, definitely your answer will be 0 only. But that 3E will not present while the computer comes here. The computer comes from here to here. By the time it reaches here, already this value is replaced by this program itself. 3007 may it is writing accumulator value which is 76 will come here. So because 76 is coming here, that is 3 is replaced by 76. So this program self modifies its value. Okay, this line will be replaced by this line dynamically while running the program itself. Okay, computer will read this, do this. By the time it comes here, it becomes 76. That's why you understand. Even you may have the doubt, sir. It can have opcode fetch and all those things, no, sir. I mean, fetch execution overlap is taken place for 2 T states. The read happens in the 3rd T state. You remember those things. Here, that is not required, but generally I am saying. Okay, is it clear? Any doubt, please ask. Lucky, Aditya. Good. So answer is not 0. Shock laga. Halt का मीनिंग क्या? कंप्यूटर विल स्टॉप द प्रोग्राम. ओके, सो इसके बाद भी अनदर halt है. Halt का मीनिंग itself it will stop the program. Okay, so let's have one more instruction. One more instruction. One more program. Yes, Aditya. No, I picked some. I think it is a previous gate question. Okay, now see this. Try this. I mean, you can try. Give a try. It is not 8085. It is 1. Okay. Otherwise, in a certain microprocessor instruction, there is 1 minute. Wait. It is not 8085. It is a certain microprocessor. There is an instruction XOR of AB equal to A XOR B will be copied to A. Okay, this instruction is available in a, okay, only this instruction. You don't, nothing, no other information is given by examiner. Okay, so don't use exchange and move, all those things. Those are not available. He told only this, we use only this. Okay, it is not 8085. One of the application, you can say so many applications are there, we'll discuss them. First, let's do this problem. Shall I do it or will you try? What is AX? I see, use this instruction and do it. Don't do AX or BX or B. What will you get? Try it. Tell me how many instructions are required, how many lines are required. Don't take other variable also. Don't take other variable also, because he don't say another variables is there. No. Yes, AB already loaded. Say A contains 30, B contains 40. I want to exchange AB. Write it and show, Dhanpal. A should get B, B should get A. Please understand that. You understand the question or not? A content should be swapped to B, B content should come to A. Okay, I will do it. A equal to A XOR B, B equal to A XOR B, again A equal to, right, Harsh? Correct. Okay, listen. First you do XOR of AB. That will give you A equal to A XOR B. First part is done. Then you do XOR of B comma A. B comma A. Now your B equal to B XOR A. But what is A? What is A now? A XOR B. Understand the logic? This will come here. But you know, this is your A right now. Okay, this is your A that will come here. Okay. Now B XOR B equal to 0. 0 XOR A. What is the answer? 0 XOR A is equal to A. So one job is completed. B got A. B is copied with A. Then do another XOR of, now another XOR of AB. Then what is your A contents? A XOR B. XOR with B. These two are to be XOR. What are the A XOR B? XOR with A. Now A XOR with A. 1 minute. A is copied with, tell me, A XOR B. What is A XOR B now? Current contents of A. Current contents of A XOR with the current contents of B. That will give you A XOR A is 0, 0 XOR is B. Now after these two instructions, your B will become A will become B. This is what we call swap or exchange without using third variable. Without using third variable. Only using A and B, we are able to do this job. Okay, I am repeating, please see. First step, A will be copied with A XOR B. Second step, B is copied with B XOR with A. But now what is A is this part. What is A? A XOR B. Because A is already replaced by this. This will come here. Because B XOR with represent A. That is B XOR B is 0, 0 XOR A is A. Finally, you will get A value. Don't say again A equal to A XOR B. Okay. Now, XOR of AB, I said A equal to this A XOR with, okay, A XOR with what? A XOR with B. So, what is A XOR B? XOR with B. B contains A. Is it okay? Good. Yes, Chaitanya. Right. Let's move to the next. Okay. So the next instruction is compare R. Okay. So let's complete these few instructions which we are having, like compare, complement, and rotate instructions. Then we can discuss further. Okay, let me complete compare instruction, complement instruction, set, carry, whatever we have. Then we discuss total problems only. Okay, let's do it. Compare A, it will check compare A with R. Okay, if by using subtraction internally, but results are not stored anywhere. Only flags affected. Only flag register will be affected. How it will do comparison is simply by using subtraction. So it will check three conditions: whether A is greater than R, A less than R, A equal to R. If A is greater than R, it will show the condition as carry 0, 0 flag 0. If A is less than R, it will show carry equal to 1, 0 flag equal to 0, like borrow. If A equal to R, carry 0, 0 flag is equal to 1. Carry 0 and 0 flag is equal to 1. Okay, so this is how it will show you the compare. Internally your registers are not affected. So it is a 1 byte instruction, 1 machine cycle, opcode fetch, 4 T states. What is addressing mode? Register addressing, and all flags affected according to the subtraction result. Because how you compare A and B? We subtract A minus B is greater than 0. Okay, then A is greater than B. If A minus B is less than 0, then I will say A less than B. A is equal to B. That is, then what will you get? A minus B equal to 0. Okay, that is internally computer will do that, but it will not show that results anywhere. So now let me give you few things about AND operation or operation. Listen, AND operation can be used to mask a particular bit or a group of bits. What is the meaning of mask? What is the meaning of mask? To make 0. What is the meaning of mask? 0. Okay, so for example, to mask lower nibble and immediately accumulator with F0 hexadecimal. Very good. That is, accumulator may be containing some number, say 23 hexadecimal. So 23 F. So whatever you have, AND operation may one of the input 0, all zeros will come. So 0 and 1 will give you 0, 1 will give you 1. So AND operation may one of the input is 1, it will give you the other input as it is. If the one of the input is 0, output is 0 irrespective of the other input. This is 20 hexadecimal. Okay, so the lower nibble is masked. Okay, similarly see here, to mask MSB. Okay, that is sign bit is equal to 0. To mask your sign bit is equal to 0, what you can do is end immediately with 7F. 7F, correct. That is, you have set accumulator equal to 23 or 33, whatever, not 33. Take accumulator equal to BC. What is BC? Now you end with 7F. What will you get? This will be 0 and remaining will come as it is. Remaining will come as it is. Forget about compare right now. Rohit. Compare time में accumulator content will not be changed. I will show you with example, don't worry. Okay. Sorry. Okay. Now see here. So suppose how to utilize this. I will give you one practical solution. How to utilize this practically. How your microcontroller programmers or embedded systems may how they will use it is like this. Say for example, you have this many number of bits, maybe 8, correctly 8. Suppose here different interrupts are coming or different alarms are coming. Okay, then what you can do? Suppose for example, you are in a industry. Okay, some system temperature is high, one alarm will come. Pressure is high, one alarm will come. Okay, fire has occurred, one alarm will come. Smoke has detected, whatever. So different cases may some different alarms are coming. Okay, by chance, okay, you want to sleep. Okay, during this time, you don't want few alarms to ring, which are not much important for you. Like fire, something, temperature, they may be important. You don't do that. So remaining what you do? You do end operation here with 0. So whatever may be your input, end with 0 will give you 0 only. These alarms will not ring in that case. This is called as masking. Okay, so whatever the output is coming, that you end with 0 and read it, then what we get, it is called masking. That is at this particular time you can mask it, or you are not using these alarms. Noise may come and ring the alarm, you don't want that, so you can mask it. So for selective masking, you can mask any single bit or all the bits. All the bits you need not mask it. Generally, you can make it 0. But I'm saying lower nibble, higher nibble, middle one, anything to mask the data, you can use this. Or to make the sign 0 also, we can use it. Is it clear? What is the application of end operation? Okay, it is a practical way people will use. Masking means kind of ignoring. Take a mask so that your corona will be masked, reflected. Even it comes here, you don't take it. Same, interrupt occurs, system don't take it. Okay. So now the next one, advantage of OR operation. Logically, okay, OR operation can be used to set a particular OR group of bits. OR operation can be used to set a particular array group of bits. This is also one of the application of OR operation. For example, okay, OR immediately with 10 hexadecimal. Then what happens? Say accumulator is having 65. Now when you are with 65 with 10, OR operation, any one of them is 1, your output is 1. Now, yeah, you can make a lower nibble to 1, higher nibble to 1, any group of bits or single bit can be made equal to 1. So this can be used to set MSB remaining as it is. That is, here sign will be 1. Here sign can be made 0. Not only sign, anything. Okay. 8080. I'm sorry. Okay. 80 hexadecimal. So you can make OR with any particular, say last 2 bits you want to make it 1. What to do? or with the last two ones. Remaining as this will come, those particular bits will be by default 1. Like that, you can force it to 1. We can force them to 1. To sign changes, okay, etc. We will be using this OR operation. Okay. Next. XOR can be used to complement a group of bits. Yeah, MSB only we see that assuming signed magnitude representation. This is in signed magnitude representation only it will work. So XOR can be used to complement a group of bits or some particular bits. For example, you say, see here, accumulator is equal to 55H. XOR, okay. Otherwise, wait. X accumulator, 1 minute. You know this rule, right? 1 XOR with A. What is the answer? Tell me, 1 XOR with A. A bar. So 0 XOR with A is A. So wherever you want same bit, you keep A. Wherever you want complement, you can give 1. Like that you can see. For example, to complement MSB, what to do? XOR immediately with 80 hexadecimal, which will complement MSB. Remaining will come as it is. You can set, you can reset, you can complement using XOR operation. Similarly, okay, MVI A comma 55 hexadecimal XOR immediately with FF hexadecimal. Suppose you do this. XOR immediately with FF hexadecimal. What happens? 5 means 0, 1, 0, 1. XOR with all ones. What will you get? 1, 0, 1, 0. Again, XOR immediately with FF. What will you get? 1, 0, 1, 0 now become XOR with all ones. What will you get? 0, 1, 0, 1. That is, it is one simple way that is can be used in the display purpose to alternatively turn on the LEDs. On, off, like pattern you see. Then again, you just use one instruction, it will make 1, 0, 0, 1, 0, 0, 1, 0, 1 like that. So this can be done with the help of XOR operation. Okay, in microcontroller, they will use the same lines to do this job. Okay, so XOR example is to complement a group of bits or a particular bit. OR operation is used to set a particular bit, and what is AND operation can be used to mask a group of bits or a particular single bit, depending on immediate data you are available. These are the practical applications of your logical operations. So now let's move to compare instruction. So let's see what happens with the example about compare instruction. For example, MVI A comma 45. Compare, otherwise, MVI B comma 65. Compare B. I want to compare accumulator with B register. How it will be done? Let us see. 45 means this one. 65. What is 65? Its complement, its 2's complement is 1001 1011. This will give you sum 0, carry 1, sum 0, carry 1, sum 0, carry 1, sum 0, carry 1, 0, carry 1, sum 0, carry 1, no carry. But carry will be equal to 0 bar, that is 1. Because after subtraction, what happens? You know the rules, same rules. And your, what is that? Sign flag will be equal to 1. Okay, what about 0 flag? 0. That is, after this instruction, accumulator will be same 45 only, but carry flag will be 1. Carry flag will be 1. And what is that? 0 flag is equal to 0, which indicates A less than B. Accumulator will not be copied with new value. This value is not stored anywhere. This value not stored anywhere. Temporary register will take care of it. Okay. This accumulator will be as it is. Your accumulator will be as it is. It will not be disturbed. Only who will change? These two. This will tell whether A less than B or A greater than B. Where is 25, man? Where is 25? I am not able to see. Here. Okay. Let's make it 25. Thank you. Okay. Accumulator is not affected. Yes, carry and 0 will tell you valid results. Carry and 0 will give you valid results. Okay. Yeah, actually AC will be 1 bar. You can take. Actually, one case may fail. That's why I'm not taking. If you want, you can take AC equal to 1 bar as 0. And parity is even 1. All those conditions. Yeah. Carry 0 means what do you mean by negative, Aditya? Already I told these results. A greater than B, carry 0. A less than B, carry 1. A equal to 1, carry 0. Z will equal to 1. Rahul? Understand? What Abneet? Who is signed man? What 0, Rahul? What do you do with the answer? Answer is of no use for us. Here you need to do comparison, not subtraction. They don't complement and store the result. It's not sign magnitude, it's 2's complement format. Here they don't store the result of the subtraction. They will only store flag register contents. Only flag register contents will be stored. No case. Carry 1 is there means A less than B. 0, 1 equal to means A equal to B. It is mutually exclusive. Okay.
Okay. Previous slide you want? Take it. Is it okay? If it is okay, I will move further. Yes, Deep. Carry equal to 1 for a less than 1. What is the problem? Here also a less than r. That's why carry equal to 1. A less than B. A less than R. That's why you got carry equal to 1. What is the doubt in that, Deep? Tell me. After subtraction, as if not every arithmetic operation. I hope you understand. Please see Deep. Wait, people. A less than R carries 1. It is less than symbol. Okay? A is less than R. That's why carry is 1. Where is the doubt? Okay. What is the people? Why only 7F for higher nibbles masking? For higher nibble masking, it is not 7F, it is 0F only. Higher nibble masking, we make it with 0F, not 7F. For MSB masking, MSB means single bit masking, we use 7F. Okay, so next. See, this is what happens during the compare instruction. Okay, second machine cycle. First machine cycle is opcode fetch. This is fetch execution overlap. Okay, internally that register is copied into temporary register. The temporary register and accumulator will be subtracted. Okay, flags are affected. No register is affected. Only flags will be affected. No register will be affected. This is what happens internally. Okay, so let's move. So compare R. Similarly, you can have CPI. It is not a party name. Okay, it is compare immediately with 8-bit data. Okay, it will check A greater than the 8-bit data, A less than 8-bit data, or A equal to 8-bit data. Okay, so same story, carry equal to 0, 0 equal to 0, carry equal to 1, carry 0, 0, 1. The story is same. Okay, then what you have here is it is a compare and 8-bit data. So how many bytes data? How many bytes? 2-byte instruction. Okay, what are there? Two machine cycles will be there: opcode fetch and memory read. 4t plus 3t, that is 7t. Next, what is the addressing mode? Immediate addressing. All flags affected. Okay. So similar to compare, we have, yeah, fetch, execution, overlap, everything is same. Comparing means even the job is left over, that is done by FU only. So the next one is okay. So compare R. Why not all flags are affected? Because subtraction is taking place now. Because of subtraction, your result changes. Result will not be stored, but according to result, flags will be affected. But this will give you significant results. Remaining will affect, but it is of no use for us. So compare R is done. Compare M. What is M? Contents of the accumulator pointed by HL register pair. It will also compare. What happened to high? HL. Okay. Why you people are saying high? High, I'm thinking that. Okay. It is a 1 byte instruction only. It will read in opcode, then go to memory, read that also. Okay. So opcode fetch, memory read, 70 states. Memory pointer means register indirect address. All flags affected happily. Is it okay? Right. Yes, it will be there. After memory read, it need to compare. FEO will be there. Okay, next. I didn't said man. Manufacturer said that. Flags affected means based on the without flags, how will you say whether compare is done or not? The operation itself purely depends on compare. Is it clear? Most of the arithmetic logical operations flags will be affected. Whenever they are not affected, we have specified it. Now we left with, yeah, we can remember, you also learn now, na? Manufacturer has given this information. Okay, I have not made any research here. Okay, less means not full-fledged people. Sometimes it is failing, na? Not completely pipeline process. Okay, let's come to the next one. Yes. So we have leftover with RAR, RRC, RAL, RLC, STC, CMA, CMC, and CMA. Okay. So what are they? rotate accumulator, all single stroke. Okay. Through carry. Okay, I'm sorry. Rotate accumulator, right through carry. Next, rotate accumulator, right without carry. Next, rotate accumulator, left through carry. That will finish your total logical operations. Rotate accumulator, left without carry. This is set carry, complement carry, complement accumulator. Is it okay? These are the group of instructions we are having here. All are 1 byte instructions. All are 1 byte instructions. Next, second, what is there here? Opcode fetch only. I'm sorry. 1 machine cycle. Only opcode fetch. 4 T states. Only 1 flag is affected by this. Sorry, sir. What is the addressing mode here? All are done implicitly, instruction having that. So implied or implicit addressing mode. Okay, lastly, only which flag is affected by these operations? Only carry flag will be affected. But there is exception. For this, all flags affected. Okay, for this all flags affected, but remaining only carry flag affected. Okay, so for set carry and complement carry, you don't need any explanation. Am I correct or not? What it will do? Carry flag will be 1. Complement carry means carry flag will be bar. Accumulator complement means accumulator is copied with a bar. So these 3 are done. We have 4 more friends to be discussed. That will finish your logical group of instructions completely. Okay, shall we move? So now by this time you will be having some feeling like that. So by understanding this, I mean you are able to understand, but how to remember all these things? Okay, once we do the problems, you will understand that. Once we do the problems, you will understand that you need not remember the things automatically. By already it is in your memory. You will feel that already it is in your memory. Okay, let me draw these rotate operations. Okay. So what happens? No, you will remember. That is the problem. Problem here is you always worry to remember, but it is there in your memory. That's why we will prove it once we discuss the what we call the magic in this microprocessor is we are studying with mnemonics. So you need not remember this line. When you see RAR, it will trigger it as rotate accumulator. Wait, Pupul, I will explain. Sorry, here one more. I'm sorry. Here, no flag is affected. I'm sorry for that. Accumulator complemented. Okay, just it will be complemented. Flags will not be affected. Okay. Why means you should ask manufacturer. Okay. Okay. Just wait. So let's do it. Just wait. These four may some people are having sir without carry, with carry, without care. I will prove you. I will show you carry will be affected in all the four cases. All the four cases, carry will be affected. Okay. I'm not wrong. I will explain you. Take a box, small box, again small box, big box. Okay, let's crack it. So this is your carry. This is your accumulator. I'm sorry. And this is your accumulator. Okay. So D7, 4, 3, 2, 1, 0. D7, D3, D2, D1. Why? D5. Okay. Okay. So let's discuss your RAR and RRC. What is the difference between RAR and RRC? RAR may this accumulator right. Right means which side? This side. Okay, this will come here, this will come here. Yes, I am lefty only. Yes. Don't say sometimes and for some tasks. Yeah. Okay. See here. You understand both the cases carry will be affected. Okay. This is rotate right. This is rotate right here, and carry is loaded here. You understand? In this case, it is 9-bit rotation. Here it is 8-bit rotation. Here it is 8-bit rotation. That is the difference. Here it is a carry comes here and this goes to carry. But here last bit will come to here also, carry also. Carry will be destroyed in both the cases. Carry will be destroyed in both the cases. Okay. You can rotate the data like moving message displays like that from output like this. Divide by 2 can be done. Shift operation. That is shift operation. Shift and multiply operation can be done. Okay. And also you can rotate the data. Yes. Some like that. Or round robin fashion, whatever. This is see here exam that manufacturer has given that we use that in a number of cases. Next, rotate accumulator left or left through carry. Now our turn. Okay. So this is rotate accumulator left. Oh, sorry, some arrows are wrong. It's a cyclic operation like this. Here, another case is this one. So here also it will do the same thing. Okay, left and right through carry without carry. Same story, 9-bit rotation, 8-bit rotation. How to do this easily? How to do this easily? Listen here. If you have 25, finally your logical instructions completed. carry equal to 0. For example, this is the instruction. If I say RAR, what is the answer? So let us see. You have this. Okay, shall I do? Instead of that easy way, I will give you. So 25 means 2 and 5. Okay, and carry is how much? 0. Okay, so one simplest way to rotate accumulator right is we cannot move every single bit. Simple way is remove this, keep it here, and remove this, keep it here. That is 0 0 0 1 0 0 1 0 and 1. Is it clear? I'm sorry. You take this and keep it here. Take this and keep it here. Simple, 2-step. No, only carry will be affected, people. No, actually, it is intention is to make carry. Okay, internal actual result can affect sign also, not only parity. Sign can also affect. Okay, can also affect, but the designer has made such that this will affect only carry flag. Okay. Right. So this is the easiest way to perform your rotate operation. Just here, actually the application of this is to rotate the data through carry. You are not doing any arithmetic operation here. Okay. He didn't made his life difficult. He made our life difficult. According to application, he will do. Okay. So is this, firstly, please tell me, is it rotate operation you understand, yes or no? Simple way to do it is remove here, keep it here. That's all. If I say same way, we'll start problems now. Okay, carry equal to 0. If I say RRC, then how it will change? Let us see. RRC mein what happens? Rotate accumulator right through carry. That is, this bit comes here and here. That is, this one you keep it here. Just remove it, keep it here. Finish. And carry will be 1. That is 92. This is 1, 2. Okay. So here don't follow blind rules. Some people will say divide this with 2, you get the answer. Okay, don't follow those things. Simplest way is this. Remove this and keep it here. Because if you make an answer, it should be satisfied for any question. Is it clear? Similarly, for rotate right also, if you want rotate left also, you can do the similar examples if you want. So you have 25 is accumulator, carry equal to 0. Okay, or 85 you take. Then you say rotate accumulator left. 85 is this one. Now simple way, rotate accumulator left na, only this bit. This bit will come here and this bit will come here. That is 0 0 0 1 0 1 0. This comes here and this comes in the top. This is 0 A hexadecimal. Similarly, you have accumulator 85H. You understand this? The simplest way, remove this and keep it here. Simple single step, you get the answer. Don't move every bit. Don't take the boxes and move every bit. It takes so much time. Okay, here. So if I say rotate accumulator left through carry, what happens? This fellow will come to here and here. That is, remaining bits are as it is. Only this one will come here and here. This is 0, A, B, C, B, H, O, B. That's so this is the about your total logical group of instructions. So let's move to what? Problems. Let's start the problems. We have 20 minutes to do the problems. Let's do happily. These are not difficult. Now my intention is to prove you that you remember the instructions easily. No need to worry. One minute. I'm not able to find the question. But read this. First do this part. Get ready. I will do it. I will load the question part. Where are they? Okay, first let's make the question. I will give you what is the. Tomorrow I will give you one extra DPP. 2 DPPs are already given now. I'm checking to download these questions. Okay, finally I think I got it. Not one. I am loading 20 questions now. Around 6 full. Okay, leave this question because I didn't find the question. If you want, we can see what's happening. Okay, leave it. So do this question first. Now, I'll conduct a poll. The contents of the register B and A of the accumulator are 49 and 3A hexadecimal. Okay, this is 3A hexadecimal. The contents of accumulator and the status flag after the instruction SUBB is. Previous question is not there. I mean, what they asked that what we call slide is missing. I am searching for that. If you want, you can do this. A equal to B5, B equal to OE, XOR this with the 69. That story can be done. I will give you that tomorrow. Don't worry. So let's do this question. Forget about that. Okay. Now do this question. Okay, if you are ready, I will start the poll. Okay. So now see here. Shall I start the poll? 49 and 3AH. Options are correct only. I have not, I remember the answer also. Let's try. Let's crack it. If I am wrong, I may be wrong also. In the sense of options, let's check it. Because I just blindly remember the value and I gave. Let's check whether it will hit or not. It's a simple question. Okay. See here. A B register is having 49. 49 का 2's complement क्या? 49 means 0 1 0 0 1 0 0. Don't take A as 49 and B as 3A. So 49 का 2's complement is 1 0 1 1 0 1 1 1. Okay. You add this with A. Subtract B now. Then what happens? A is 0 0 1 1 1 0 1 0. 3A. Add this 1 0 1 1 0 1 1. You get 1 plus 1 sum 0 carry 1 1 plus 1 sum 0 carry 1 1 plus 1 sum 0 carry 1 1 1 1 1 1. No carry. So carry will be 0 bar, that is 1. Sign flag will be 1. Your answer will be F1. No difficulty in the question. It's a simple math. Carry should be complemented. Good. So let's see. This cannot be done now. Jump instructions tomorrow we discuss. Okay. So I have uploaded this. So yeah, read this question. We can try this question. The following 5 instructions were executed on 8085 processor MVA A, 33, B, 78, add B, complement N, A, and immediately with 32. The accumulator value immediately after the execution of the 5th instruction is. Okay. Done? Good. Okay, let me also calculate. I'm doing the calculation. Okay. Done. Good. Wow. Nice. Most of you have given right answer. No means you remember the things. See here, while seeing the instruction, you are able to automatically remember the things. This is the top 10. Suraj, today 3 by 3. Good. So it's nothing difficult. Most of you have already given right answer. Accumulator is 33. B register is 78. Now add B, that is in this case, accumulator will be copied with A plus B. That is 33 plus 78. That is B, A, hexadecimal. Okay. Complement A. AB means what? 1010 1011. What is the complement of this? 0101 0100, which is 54. Okay, so here accumulator will become 54. Then last part, what is that? And immediately with 32. And immediately with 32. 32 means, so which will give you 0, 0, 0, 1, all zeros, which is 10 hexadecimal. That's all. Right. Okay, next question. This is not required now. Store accumulator. Okay, read it. An 8085 microprocessor executes the instruction STA1234 hexadecimal with the starting address of 1FFE hexadecimal. He is very kind. He has given that store copies something, everything is given. While the instruction is fetched and executed, the sequence of values written in the address pins A15 to A8 is. Okay. Simple question, not much difficult. Okay, ready? He asked in address pins. Okay, are you ready? Good. Tomorrow starting we discuss more questions. Shall we discuss tomorrow or doubt session? I think tomorrow will be better to discuss more questions. Why so many very less number of right answers? Good. Right. So firstly, please understand. So the first line will be at 1FFE, then 1FFF, then 1F, sorry, after 1FFF, 2000. This is where your data will be stored with opcode fetch of STA like 32 hexadecimal, then what is that? 1, 2, 3, 4. Now first 3, 4, then 1, 2. Okay. Then what happens? It will go to the location 1, 2, 3, 4. And there some data is there, it will copy it. Okay, it is doing memory read, memory write now, store accumulator. opcode fetch. This is what we discussed earlier. Now see here, store contents of accumulator. So first here he asked a very simple question. He asked what is the contents of address bus, higher order address bus. Okay, you don't ask which T state, nothing. Simply he asked the higher order address bus. So first, what is the answer? 1F. Second, 1F. Next to 20. Next, 1, 2. Now, no difficulty in the question. Okay, A7 to A0. In the first T state, it will be this much. Second T state, it will copy opcode. Okay, that we know it. Nothing difficult in that also. In that case, he will say the T states. Right. Let's do this. I'll take little time. Just one more question, then we can end. What I told the people, same thing, you remember or not? First it will take this, then it will take data. First it will take this, then it will take data. First it will take this, then data. First it will take, then accumulator value into that. What is the problem in that? It will take in the first T state, this will take in the second T state and third T state. So do it fast. Assume the carry flag is initially reset. The content of the accumulator after the execution of the program is ready, guys. Okay. So I have loaded more number of questions. From today's discussion, whatever the instructions are there, complete. Remaining we can do tomorrow. I mean, after remaining instructions also. We do all the questions. I have few more questions tomorrow also I will give you. Will you try it? We can discuss tomorrow, or you want me to do it now? Okay, fine. So these are for your practice. You can try the questions. 20 questions are uploaded. You can try. Fine. So let's end the session. Tomorrow morning we can meet again. Bye bye. Good night. Sora, maybe tomorrow it may complete almost. If instruction is completed, your almost microprocessor is done. If instruction completed, one more class is just required. That's all. Okay, because now we parallelly do programming also. Okay. Bye bye. Good night.